Number one here is an alternating series because you got the sigma, you got the minus 1 to the n. So this is an alternating series with b sub n equals 1 over n times natural log n. Okay, and that function right there, that is clearly decreasing, right? As n gets bigger, this gets smaller, and it's decreasing, and it goes to 0 as n goes to infinity. So it definitely converges by the alternating series test. Okay, so the only question is, we know it converges, the only question is, does it converge absolutely? And to do that, we need to take absolute value. Okay, so let's look at the sum from n equals 2 to infinity absolute value of minus 1 to the n over n times the natural log of n. Okay, well, basically what that's going to give you, that's just, the minus 1 to the n is just always going to be a 1. And n and natural log of n is always bigger than 0, so no more absolute values needed there. So really we just need to know, is this series convergent? And this one's a little tougher because it's not a p series. It is, right, the terms do go to 0, so we can't say it diverges by the divergence test. Actually, the best way to handle this is with the integral test. We would look at the integral from 2 to infinity 1 over x times natural log x dx. And I would do this integral by a u substitution. U equals natural log x. Du would be 1 over x dx. And notice that works perfect because you have a 1 over x dx in the problem there. So this is actually going to be the same as the integral it's going to be it's going to be the integral from 2 to infinity 1 over, and this here is u, this right here is u, and then the 1 over x dx just becomes the du. Now it is it's an integral from 2 to infinity, so technically it's a limit as b goes to infinity. The integral of 1 over u is natural log of u, and we have to evaluate that from 2 to b. But technically, what was u? U was the natural log of x. So really we have the natural log of the natural log of x evaluated from 2 to b, which is, so we'd have the natural log of the natural log of b minus the natural log of the natural log of 2. Alright, as b goes to infinity, the natural log of b goes to infinity, so the natural log of that also goes to infinity, albeit extremely slowly. Okay, but this limit actually is infinity, which means that that particular series, or that the integral diverges, which means that the series diverges. Okay, so what is the conclusion here? We knew that the series, we knew that the original series converges by the alternating series test. We tested it for absolute convergence, and we saw that it is not absolutely convergent, and so therefore it must be conditionally convergent. Alright, it's conditionally convergent because it converges, but not absolutely. Alright, number 2 is a perfect candidate for the ratio test. Okay, we'd want to take the limit as n goes to infinity of a n plus 1 over an. Which, let's see, what do you, how do you do an plus 1? You look at your formula here, everywhere you see an n, you replace it with n plus 1. So you'd have a 2 to the n plus 1 over 2 n plus 1 factorial. That would be an plus 1. And then you're dividing by an, which is the same thing as multiplying by the reciprocal, which would be 2n plus 1 factorial over 2 to the n. Okay, let's see, let's try to rearrange that a little bit. So first of all, you do have a 2 to the n plus 1 on top. Basically, I'm going to flip-flop the order of multiplication on the bottom here. Okay, you're allowed to do that. So yeah, so you have a 2 to the n plus 1 on the top, you have a 2 to the n on the bottom. You have a 2n plus 1 factorial on the top. Really down here, once you distribute the black 2 to the red n and 1, you'd have 2n plus 3 factorial. Okay. Both of those can be simplified. 2 to the n plus 1 divided by 2 to the n, that's just 2. And then 2n plus 1 factorial over 2n plus 3 factorial. Notice that this number here is always 2 more than this number. So let me let's just run a quick example here. What if n was 3, for example? Okay, this would be 7 factorial over, let's see, that would be 9 factorial. And this is this right here is 7 times 6 times 5 times 4 times 3 times 2 times 1. This one is the same thing, but it starts with 9 times 8 times times all that stuff. So what's going to happen is everything is going to cancel except for the 9 and the 8. All right, and so that's what happens when n is 3, and the same thing happens for every n. So this is going to be 1 over, and then you're going to have a 2n plus 3 times a 2n plus 2. And yeah, all the other factors in the factorials cancel. Okay, now you are taking a limit as n goes to infinity. As n goes to infinity, this fraction here is just going to be 1 over a huge positive number, so it's going to go to 0. And 2 times 0 is 0. Okay, so you did the ratio test. We saw that the limit was equal to 0. 0 is less than 1, which means that this series converges by the ratio test. Okay, what does it converge to? I have no idea. I suppose you could approximate it with, S10 or S50 or something, but we really don't have any error theorems for this type of series here.